Friends, welcome back. I still remain your homeroom teacher. Today we are going to kick off from where we stopped in our first video, which was on that topic differentiation. So in order to finish the topic differentiation, we are moving to the next segment of the topic, which is differentiation by chain rule. So today's video is going to be an half a video of the full disclosure, the full teaching of the definition of chain rule. So I'll be teaching half of it today with only one example, and I'll be teaching the remaining half in my next video. So stay tuned for the next video. So we're going to kick off for the first part of differentiation of chain rule. What is differentiation of chain rule? Let us begin. Let's say we have this differentiation equation which states y is equals to x into bracket x plus 1 raised to power 10. We should see here that the exponential mentioned here is 10. Normally, doing quadratic equation, we are known to open a bracket. But if we should open the bracket 10 times, so to say, and multiply all together, it's going to be a very strenuous activity. And we will not be able to know the differentiation of that equation, so to say. So how are we going to do so? Instead of opening the bracket x plus 1, x plus 1, x plus 1, x plus 1, well, so how are we going to solve this differential equation without opening the bracket, that is the quadratic equation x plus 1 or exponential 10? It is very easy. We now say that we bring in another variable, that is what we call a dummy variable in differentiation equations. And this in this instance, we let z be a dummy variable for x plus 10. So that means z is covering everything for x plus 1. So that is z equals to x plus 1. Since we've named the dummy variable to be equals to x plus 1, then we'll take that dummy variable to the main differential equation, which is y equals to x plus 1 exponential 10. Then we'll place the dummy variable into the equation. Therefore, we are having y is equals to z exponential 10. Now, since we have our dummy variable into the equation, we now have y is equal to z exponential 10. And remember from the first video, I mentioned about a general method whereby you can use to solve differentiation equation easily. We take in that general method now, and we go back, and therefore we have y equals to 10 times z 10 exponential 10 minus 1. Remember in the last video, I said in the first video that I said that when differentiating, the exponential of the old equation is always minus by 1. So therefore, we minus 10 minus 1. So now we've gotten our answer for differentiating z raised power 10, and we have 10 z raised power 9. If you notice, we are seeing that we are having the y the z instead of the y the x. Why is this so? Because in differentiation, when you are trying to differentiate an equation, it is two variables that are mentioned in the equation. It is what you are meant to use for the differentiation equation. Now remember when I said that the equation is not solved at the end? Yes, because if you should remember, we see that z is z equals to x plus 1, and that dummy variable has to go. We have to do I have our dz dx, and using the general formula method, our dz dx of this equation is equals to 1. No comment, no dispute about that one. Is equals to 1. We've been saying the y the z the x, or whatsoever, but we've not gotten the main objective, which is the y the x. So what is now differentiation of chain rule that I asked the question before? Well, this is differentiation in when it involves chain rule. According to how I put it, or how I feel comfortable on the topic of differentiation by chain rule, well, I'm saying that differentiation of chain rule, that is the y of the y dx of chain rule, is the multiplication of the differentiation of the two different variables, both the initial variable and the dummy variable. When you I have those together, then when you multiply those together, Then you have the differentiation of chain rule. So this is the representation of my definition. You can see here that the y dx, that is the differentiation of an equation using chain rule, is equals to the dy dx of one variable and multiplied by the dz dx of the other variable. You can see that dz here is the both the denominator and the numerator of one of the two of the variable, is the denominator of the first variable and the numerator of the second variable. So this can cancel each other to form dy dx. So now the differentiation of the initial equation now is the multiplication of the differentiation of those two variables. And those two variables that you have seen before, 10z exponential 9 and 1, when we multiply together, still have the same result, which is 10z exponential 9. I haven't gotten to this point. Do you think that is the end of the equation? No. It still remains one thing. We need to eliminate the dummy variable z, and z is already in our divide x. So how do we eliminate the dummy variable? Let's see. Now, how do we get to this final answer 10 into bracket x plus 1 exponential 9 when we have still have z? Well, remember that z is equal to x plus 1. So we should interchange those values into the answer. We get our final answer, which is 10 into bracket x plus 1 or exponential 9. So that is the final answer for today. So we've come to the end of the first part, or differentiation by chain rule. And the next video is a must watch video because I'm going to wrap up differentiation by chain rule, and I'm also going to introduce differentiation by product rule and just give out the formula. So stay tuned for the next video, which I'm going to be dropping anytime now from now. So see you guys later. Thank you and have a great day.